Hi, this activity really goes along with activity 6, and so there's going to be two videos. The first one is going to be for lesson 6-1, and we're going to cover some function notation and also some operations with functions. And so we're not going to be using the lesson from the text for 6-1 or 6-2, and actually not for 7-1 and 7-2. So in the warm-up, they're asking us to just practice some combining like terms. I know we've been doing that, but just to remind you of how to handle quantity squareds and things like that, we'll go through each of these. So in part A, we have 4 times x minus 2 squared. So remember that's x minus 2 times x minus 2. And then we still have plus 3x minus 10x, and we still have plus 7. So when we do a little FOIL, we get 4, and that's going to be still times, and we're going to have x squared minus 2x, and minus 2x is minus 4x, and then plus 4. And then we still have plus 3x minus 10x plus 7. Okay, and then we'll do one more distributive before we can combine like terms. So we get 4x squared minus 4x. Back it up. We get 4x squared, that part was good, minus 16x plus 16, plus 3x minus 10x plus 7. So now I think we're ready to combine our like terms. We've got a 4x squared, and then we have a negative 16x and a positive 3x, which is negative 13, but then minus 10x, negative 23x, and then 16 plus 7 is actually plus 23. And so we combined all of our like terms. Okay, in part B, it's not quite as much work. A little distributive, and then we'll combine. So we get negative 3x plus 24. Then we get plus 16 minus 4x, and then we have a plus 2. And now we can combine everything. So our x's are negative 7x. And for our constant, we have 24 plus 16, which is 40, plus 2, 42. Okay, and there's our final answer. So we'll be doing a little bit of that as we work with function notation. So notice the f of x expression. So that is a function that's written in terms of x. Okay, so we'll be substituting in for x when we're told to find f of, let's say, in part A, we have to find f of negative 4. And so if we need to do that, well, we just want to put in negative 4 everywhere we see an x. So we have negative 4 squared minus 2 times negative 4. So remember, negative 4 squared is negative 4 times negative 4. That's 16. And then minus 2 times minus 4 is actually plus 8. And so we'll get 24 for that one. For part B, we have to just plug in a y wherever we see x. So that seems a little tricky, but it's actually not that bad. So it's going to be y squared minus 2y, or just y squared minus 2y without the parentheses. Okay. If we want to sub in a smiley face, we can, like in part C. So that's going to be smiley face squared minus 2 smiley face. Okay. And where it gets a little tricky is when we're plugging in a quantity like x plus 3. So I need to put x plus 3 quantity squared minus 2 times x plus 3. But we've been practicing, and we know that we have to write that twice and FOIL it. So x plus 3 times x plus 3 minus 2x minus 3, if we distribute the negative 2. So that FOILs out to x squared plus 6x plus 9 minus 2x minus 3. Combine like terms, and we get x squared. We get 4x, and we get plus 6. And that is our final answer. Okay. All right, so some function operations. We'll get used to some notation things here. So if f and g are functions, a new function h can be defined by performing any of the 4 basic operations with f and g. So addition sometimes looks like this. Say find, f of x plus g of x. Okay, so like if we wanted to do that, we could take our f of x, which is 5x, and we could add that to our g of x, and that makes 6x plus 2. Okay, so that's just adding the functions together. Okay, now subtraction, like always, like our polynomials, subtraction can be a little bit different. So we want to make sure we're careful when we do f of x minus g of x. Okay, so we have 5x minus x, and it's actually minus 2 if we distribute. So I'm going to write that out. It's 5x minus 2 means it's really 4x minus 2 for our answer. So careful with your distribution. Always distribute your negative. Okay, so let's try multiplication. So for multiplication, that could be distributive, it could be FOIL. They'll ask you to do f of x times g of x. In this case, since it's a monomial times a binomial, it's just a little distributive. We'll get 5x squared, and we'll get plus 10x. For division, if we wanted to divide, let's say we wanted to divide f of x by g of x. We're probably not going to be able to do much with that problem. And the reason is we don't really know polynomial division yet. So if I was going to do f of x divided by g of x, okay, if I was going to do that, then I would just simply write 5x over x plus 2. But one thing we have to always be careful about is not making a denominator that would be equal to 0. So oftentimes we have to kind of check our domain on a problem like this. So you might hear, well, what's the domain of the problem? Well, the domain would be, you can let x be anything you want, except one number in this problem. What number would create the bottom, make the bottom a 0? And so what we'd have to say is x cannot be that number. And so if x plus 2 equals 0, well, negative 2 plus 2 equals 0. So we kind of have to think about what number are we not allowed to have. But we're not actually doing division in this problem. Okay, so we're just kind of like defining division here. Okay, so let's see what we have going on next. In example 1, they've given us our polynomials. They said that f of x is x minus 1 and g of x is x squared. And they want us to do two operations. They want first us to do f of x plus g of x, then they want us to do f of x times g of x. So we want to do both of those. So I do want to show you an alternative notation as well. So sometimes they'll write f plus g, and they'll put it like that with x on the side. So just so you know, you will see it like that sometimes. All right, so we need to take x minus 1 and add it to x squared. And we really can't do that. We're just going to write x squared plus x minus 1. Okay, and that's f of x plus g of x, or f plus g of x. Now multiplying, I'd probably stick the monomial in the front. And this we can actually do a little distributive. So we'll get x to the third minus x squared. In example 2, we've got a subtraction and division problem. Okay. And we got two new functions. We've got p of s is s minus 4 times s plus 3, and v of s is s plus 3. So the first thing they want us to do is subtract the functions. Okay, well, to subtract the functions, I first want to show you that other notation. So you might also see, p minus v of s. So p minus v, and then you'll have your s like that. So you might see that too. But the easiest way to subtract would probably be to FOIL first. So I'm going to go ahead and take, s times s and get s squared, and then 3s, take away 4s is negative 1s, and then negative 12. So that's p of s, and we want to subtract off v of s, so we want to take away s plus 3. Okay, so like I always do with my subtraction, keep the first polynomial the same, subtract s and subtract 3. So kind of doing distributive there. And so we get s squared. It looks like we're going to get minus 2s. And finally, minus 15. When we do v of s divided by p of s, this one will be nice to keep the factored form, because if we take v of s on top, that's s plus 3, p of s on bottom, we have s minus 4 and s plus 3. We've written it as a division problem, but we can help. We can find our domain much easier by looking at the bottom and what would create that 0. So there's 2 places where we would get a 0. If s were 4, 4 minus 4 is 0, so that's no good. And if s were negative 3, negative 3 plus 3 would be 0, so that's no good. So our domain, we could actually write, is that s cannot be 4 or negative 3. Okay. Now, you want to do your domain before you do this next step, because technically we could simplify part B. But I didn't want to do this before I did my domain, because now if you notice, you have an s plus 3 on top and an s plus 3 on bottom. So technically we can write 1 over s minus 4. But you have to make sure you still include for your domain that negative 3. That cannot be an s. Okay, so that's pretty much for day 1's notes, and you're going to have some problems to do on a handout, and we'll work on some of them in class as well, just to get used